6i. Note that here 6i is only an imaginary number, so there is not any real part, so real part is equal to 0, that is x is equal to 0, and imaginary part, that is equal to -6, so y is equal to -6. So the modulus is in root x square plus y square, that is 0 square, that is 0, -6 square, that is equal to 36. So we will get root 36, that is equal to positive square root of 36, that is 6. So here modulus of -2 plus 5i, that is equal to root 29, and modulus of -6i, that is equal to 6. From this discussion we can give one conclusion, that here the modulus of -6i is greater than modulus of -2 plus 5i. So we can say that which of these two complex numbers is closest to origin. We know that the modulus of any complex number is the distance of that particular complex number to the origin. If the modulus is less, then the distance is less. So here we can now say that the complex number -2 plus 5i have the modulus in root 29, and the complex number -6i has the modulus 6, which is greater than root 29. So -2 plus 5i is the closest complex number between these two from the origin. So answer is -2 plus 5i. Here -2 plus 5i is closest to origin, right? So from the modulus of any complex number we can give the decision that how far this complex number is from the origin. Okay, so this is the idea of that particular thing. Now before we move to the square root of any complex number, I want to solve some examples based on the modulus of a complex number and the conjugate complex number. So let us look at some examples. If we have the question that find conjugate complex, find conjugate complex number and the modulus of following complex number. And the question, the complex number is z is equal to -3 plus 7i upon 1 plus i. We need to find the modulus of this complex number and conjugate of this complex number. So first we need to convert this complex number in its regular form, that is x plus iy form. So first I want to remove this complex part from the denominator, as we have discussed how to find the inverse of any complex number. In that part we have discussed how to remove the complex expression from the denominator of any complex number. So here I will multiply this one with here 1 plus I, so I will multiply it with 1 minus I, and here also 1 minus I. So I will get -3 plus 7i into 1 minus I upon 1 minus I square. Okay, and by simplifying this expression, I will get, by the simplification of this one, I will get is equal to here minus 3 into 1, that is minus 3, minus 3 into minus I, that is plus 3I, 7I into 1, that is plus 7I, and 7I into minus I, that is minus 7I square upon 1 minus I square, that is equal to minus 1. I square, here I square is equal to minus 1. So here I will get minus 3I plus 7I, that is equal to 10I, minus 7 into I square is equal to again minus 1. So here 1 plus 1. So I will get here minus 3 plus 7, minus 3 plus 7, that means 7 minus 3 is equal to 4 plus 10I divided by 2. Okay, and dividing by 2, I will get this is equal to 2 plus 5I. So I will get Z is equal to here 2 plus 5I. The question is, this is our question, we want to find the conjugate complex and the modulus of these complex numbers. So first I will convert this complex number into regular format, that is in the x plus iy format, by this kind of calculation. So I will, in the end, I will get Z is equal to 2 plus 5I. Okay, so 2 plus 5I, so I can say the conjugate complex Z bar is equal to, we know that the real part and imaginary part will be the same, but the sign is the different one. So Z bar, which is the complex conjugate of this complex, that is 2 minus 5I. So conjugate complex of this number is 2 minus 5I. And if we want to find the modulus, then modulus of Z, that is equal to in root x square plus y square. In this case, x is equal to 2 and y is equal to 5. So I will get mod Z is equal to in root 4 plus 25, that is equal to in root 29. So in this way we can find the conjugate of any complex number, and we can find the modulus of that particular number. Okay, so this is the idea of the conjugate complex number and the modulus of a complex number. So now let we move to our next topic, and which is how to find the square root of a complex number. So here, if we want to find a square root of number x plus iy, then if a plus ib whole square is equal to x plus iy, then a plus ib is called the square root of the complex number z is equal to x plus iy. And by the simple calculation of the this equation, a plus ib whole square is equal to x plus iy, by simplifying that particular equation, we can easily get the values of a and b, which will be, I have written here, a is equal to plus or minus in root modulus of z plus x upon 2, and b is equal to plus or minus in root modulus of z minus x divided by 2. So by this values of a and b, if I put these values in a plus ib, then I will get the square root of the number x plus iy, which is equal to a is equal to plus or minus in root mod of z plus x divided by 2, and b is equal to plus or minus mod of z minus x divided by 2. Okay, so in this way we can find the square root of a given number. So in next session we will discuss that how using this formula how can we find the square root of any complex number, and how can we find the amplitude, or I can say argument, of a given complex number. And then in the end we will discuss the De Moivre's theorem to find the nth root of any given complex number. So we will discuss these things in our next session, which is from 2 p.m. to 3 p.m. So that's it for this session. Thank you very much.